a functional equation, and it's very, very similar to the process you would do if you were just solving a linear system in two variables. You could think of f of x as a variable, but what I mean by eliminate right here, we mean eliminate f at negative x, since we're trying to find f of x. We want to eliminate f at negative x. Okay. Now, since we only have one equation, how can we use elimination? Well, that's why we substitute negative x into the original functional equation. All right, and when we do that, if we substitute negative x into the original, it's very straightforward. You just place negative x right here. That makes it 2f of x. You replace negative x right there, and you get this. And then you lose this sign if you place a negative x there, okay? Now, so we have two different equations now. They look about the same, but the signs are different, and so that's where you can see the elimination will come into play. What I did was, in an effort to eliminate f of negative x, I did a multiply by 5 right here. Mult 5. Okay, multiply abbreviated mult 5. Multiplied I multiplied the given equation by 5. Okay, so I took this 5 and multiplied it by the given, getting this statement right here. Okay, now we're trying to eliminate f of negative x, so it follows that our derived result, we can multiply it by 2, right? We can multiply this derived result by 2, mult 2. Okay. Multiply this object by 2, and we do get a circumstance where the f of negative x terms will eliminate. All right, and so when you subtract these two equations from each other, these two terms eliminate. 25 minus 4 is 21. 35 minus 14 is also 21. And negative 30 minus 12 is minus 42. Now this solves out, that doesn't always work out so nice like this, I don't think, but if you divide by 21, we get f of x is equal to 1 minus 2x, which is linear and should have been anticipated. In fact, I think it's probably necessary, it must be linear, right? The original equation, we're dealing with an unknown function, don't know what form it's in, but the right-hand side is linear. So it's hard to imagine the left-hand side being anything other than linear. It's hard to imagine it being cubic, quadratic, whatever, quartic, right? So there's probably a rigorous proof for that, but we won't go into that. But anyway, we did get a solution here. F of x is equal to 1 minus 2x. Now let's just check it out for just like, let's say x equals 0. If you try out x equals 0, that's always a simple try. If you try x equals 0, is going to lead to 7f at 0 equals to 7, right? That's trivial. 7f at 0 is equal to 7, but that certainly intimates that f at 0 is equal to 1, okay? Okay, but that's, again, y'all, I'm just using this part right here, substituting 0 in, right? This is our original equation. You get f at 0 is equal to 1, but right up here you can see that f at 0 is equal to 1. Okay, so that proves it for one integer, namely 0. This is the answer to the problem, by the way. But let's check it out more in general, okay? So we know that f of x is equal to, we claim f of x is equal to 1 minus 2x. Now, so if you do this, if you substitute negative x into this expression, you get 1 plus 2x. So this would be 2 times 1 plus 2x. And y'all, what I'm doing is just establishing that we didn't make any mistakes. This is just all reversible stuff. So this is 2 times 1 plus 2x, because if you put a minus x right here, this becomes a plus, right? Okay, and then we have plus 5 times 1 minus 2x. And you'll note when you do the work here, when you expand out the left-hand side, you get, what is this, 2 plus 5 is 7. So you do get 7. Now, just to show the work here, we have 7 plus 4x minus 10x, right? But that is definitely equal to this, right? So it checks. All right, folks, so that's that. Fairly straightforward. The linear functional equations are really pretty easy. This is an ISI Indian entrance exam type question, I believe. Hope you enjoy.